Hi friends, here is a nice problem, very easy problem, but there is a small trick involved. That we have three equations, but the third equation is in terms of squares. That x plus 2y whole square minus z square equals 15. If they have three linear equations, then we could solve them very easily. But here there is a square, difference of squares. But we can also notice this is in the form of a square minus b square where a plus b and which can be factored into a plus b into a minus b. A minus b is nothing but this, right? So we can factor this and use this to solve this set of equations. Let's see how. The third equation we can write it as x plus 2y plus z into x plus 2y minus z, because this is in the form of a square minus b square, a plus b into a minus b equals 15. But x plus 2y minus z is already 5, which is one of these equations, right? Then what will happen to this one? X plus 2y plus z into 5 equals 15. So x plus 2y plus z equals 15 by 5, which is 3, right? Now again we have a set of three equations. This equation basically reduced to this, right? So let's take all the three equations. X plus 2y minus z equals 5, x plus 2y plus z equals 3, and 3x plus 2y plus z equals 11. Right. Now let's do 3 minus 2. Right. Wait. Right. Because we have 2y plus z, 2y plus z common in both the places. So 3x minus x, which is 2x, equals 11 minus 3, which is equal to 8. So that means x equals 4. So we have figured out what is x. Right. Now let's do 1 plus 2. 1 plus 2, then 2x plus 4y. Z and z will get cancelled, equals 8. Right. Now x is already 4, so 2 4s are 8, and so y has to be 0 here. Right. 8 plus 4y equals 8, so y has to be 0. We know x equals 4, y equals 0. Let us substitute both of this in the first equation, x plus 2y minus z. So that means 4 plus 0 minus z equals 5, z equals minus 1. Right, guys? Very simple problem, just that this has to be factored considering that this is available. Right, guys? Thank you.